Hi, everyone. Welcome to the last day of our virtual workshop on health information exchange standards. My name's Linda Bird, and I'm an adjunct assistant professor here at the University of Victoria and the instructor of UVic's HIMP 537 course on health information exchange standards, which is hosting this 3-day workshop series. So, welcome, everyone. But before we get started, let's begin with our territory acknowledgement. We would like to acknowledge and respect the Lekwungen, Songhees, and Kosepsum Esquimalt peoples on whose territory the university stands, and the Lekwungen and Wasanich peoples whose historical relationships with the land continue to this day. So we've had 2 wonderful workshops already, and today is the final day of our virtual workshops. It's now Thursday, April the 30th, so today's focus is all about HL7 FHIRE, which stands for Fast Healthcare Interoperability Resources. Now, like the previous 2 days, we're going to start with our guest presenters, and then after those, I will be staying on with the students of HIMP 537 to work through some hands-on activities, all related to FHIRE resources, profiling, and terminology. So if you'd like to join us for those activities next time and get a better understanding of both terminology and interoperability standards, you can enrol in the University of Victoria's Certificate in Health Terminology and Interoperability Standards. This is a 1-year part-time program with 4 graduate level courses done through weekly online evening classes, plus this virtual workshop. This is the only terminology standards program in Canada that's accredited by CHIMA, the Canadian College of Health Information Management, to become a certified terminology standards specialist in Canada. So if you'd like to join us for our September 2026 intake, please apply by June 15th. And to find out more, you can either scan the QR code or visit us at uvic.ca/HIMF. So here's today's agenda. We have 2 wonderful speakers today to present on FHIRE topics, Lloyd McKenzie and Sheridan Cook. And first up, we're very lucky to have Lloyd McKenzie with us to present on FHIRE questionnaires and maps. Lloyd was first exposed to healthcare standards in 1999 and left his job at IBM in 2003 so that he could focus on standards work full time. He's been consulting in the healthcare interoperability field since then. Lloyd is one of the initial architects of the FHIRE standard and has been involved with a wide range of interoperability projects, both here in Canada and internationally. He's currently a member of the FHIRE Management Group, the HL7 Technical Steering Committee, and co-chair of the FHIRE Infrastructure Work Group. He serves as Chief Standard Officer at Dogwood Health Consulting. And when he's not playing with standards, he's probably playing D&D with his kids or practicing Taekwondo. So we're very lucky to have Lloyd with us today to share his extensive FHIRE knowledge with us. Thank you so much for joining us, Lloyd. I will pass the floor over to you now.
Alrighty. Are we recording and did you want to record?
Yes, we are recording. Thank you.
Excellent. And is my screen visible?
It is perfect. Thanks very much, Lloyd.
Technology that functions. Yay. All right. So I'm going to talk lots, but I'm totally happy to have questions at any point. I'm not sure whether you guys can come off audio to ask or just stick stuff in the question box, but if anything is unclear or you would like me to go off on a tangent, I'm more than happy to do that.
Just to let you know that the students can come off mute, and I'll keep an eye on the Q&As and let you know if there are any timely questions to answer.
Awesome. Wonderful. This deck is actually available as Creative Commons. Linda has a copy. If you would like a copy, just ask her nicely and I'm sure she'll give it to you. The only request is that you give credit to the people who helped write it. So I'm giving credit to Brian Postlethwaite, who's a longtime member of the Structured Data Capture Work Group at HL7. And I've thrown myself in there, so you can just use it as is. So forms and questionnaires and all those wonderful things. You cannot go anywhere in healthcare without encountering a form of some sort. We have forms for assessments, we have surgical checklists, we have admission forms, we have discharge forms, we have referral forms, we have insurance forms, um, we have forms for case reporting, we have forms for research, we have forms to do all kinds of things. And so it's not a surprise that in the fire standard, we decided that there was a need to have some sort of structure for that. Now, why would you want a resource that's specifically for questionnaires? Why wouldn't you use one of the others? And the answer is because there's so many others. If you wanted to do a generic admission, you're probably capturing allergy intolerances, you're capturing conditions, you may be capturing family member history, you're capturing medications, observations, patient demographics, lots of other things. And that's a lot of stuff for a particular system to have to manage, particularly if it's not a terribly bright system. And there is lots of software in the world that wants life to be very simple. And there's nothing simpler than here is a list of questions, please capture the answers, and you don't need to worry your little head about what that data happens to mean. And so we have a questionnaire response resource that can capture absolutely any information that you can imagine from any resource that exists, and for that matter, even resources that don't exist. Uh, and that's an attractive value proposition. However, there's reasons other than that. Uh, if you're using an allergy intolerance resource, you're using an observation resource or something like that, you don't have much control over what the user experiences. You don't have control over the label or the question text. You don't have control over the order in which things are presented or rules around what has to be asked when. You don't have any ability to say, I want this to be red or bold or appear in a table or anything like that. You're at the mercy of whatever that particular client system happens to do. And if you're gathering data across a bunch of different client systems, the user interface experience could be completely different in all of them. And there are times when variability in data capture is a bad thing, especially research, but sometimes in other places as well. And so it's sometimes helpful to have that level of control, and questionnaire gives you that. Forms aren't, however, only useful for display. So this is a sample of a paper form for a birth record, or actually the full record tracking pregnancy. And somebody who's familiar with this form can take in a new patient, glance at this, see exactly what they want, know exactly where the information is, and consume a lot of information very quickly. And you can do that because you have that consistent representation. And so if you are receiving data from a whole bunch of different places and you want control over your user interface that is different from how your particular EMR or EHR happens to have laid things out, questionnaire gives you a mechanism to do that. And so questionnaires can be useful not only for data capture, but also for data representation and display. So if we can do absolutely everything with questionnaire response, why do we bother with all of the other resources? And the answer is because every questionnaire is different. If I wanted to search through questionnaires to find, is this patient allergic to penicillin, it would be a very difficult job because I wouldn't know which forms actually capture that information. I wouldn't know which questions represented that. Even if I saw the code for penicillin in the form, I would need to understand the question text to understand whether this is an assertion that the patient is allergic or the patient was on it, or I'm thinking about prescribing it, or all kinds of other things. And the text of the question isn't necessarily going to make that very obvious because it's not computable. I mean, you can throw AI at all kinds of things, but if we're going to throw AI at stuff, then we're not really talking about standardization anyhow. The other thing is that forms are not stable. The admission form for a particular clinic, the referral forms for a particular clinician will change over time as either healthcare evolves or the desires of that particular organization evolve, as regulations evolve. And furthermore, the meaning of elements can even change uh, within the form based on where that particular question appears. So if you have text that says name, I mean, we know what a name is, but is it the name of the patient? Is it the name of their next of kin? Is it the name of the practitioner? Is it the name of the organization? There's all kinds of different things that it could be. And so it's very difficult to count on forms when you're trying to share information across systems, but it's very useful when you're trying to do data capture within the scope of a particular system or to ensure consistency of capture. The other consideration is that the questionnaire response resource doesn't support searching by data, or at least doesn't support it terribly well. And the reason for that, again, is it's complicated. It's not just enough to say, here's the question code, look for a question code with this answer, because the meaning might be influenced by a parent question or group. And so you actually need to provide an entire path to be confident that you're getting particular meaning. And so when you're trying to do that data retrieval, questionnaire responses are not necessarily great. You can easily go and find questionnaire responses for a particular form, or that were filled in a particular date, or that are associated with a given patient. But if you're trying to search based on the answers within it, then that's much harder. So in practice, we typically meld these two patterns together. We will use forms for data capture. We'll do that when we're either working with simple clients, so ones that are not terribly sophisticated, that we want to be able to capture all kinds of stuff, but they don't want to have to understand all the different resource structures where that stuff might live, and or where we have really tight constraints over what the user interface needs to look like as we're capturing the data. When we're doing that, sometimes it's also useful to be able to fill in some of the answers. I know those of us who have enjoyed paper forms going to visit your dentist or your chiropractor or your clinician, they will give you a form and it will ask yet again for your name and your phone number and your provincial health number and your allergies. And you know for a fact that they have 95% of this information already in their system. And wouldn't it be nice if they gave you a tablet that was already pre-filled with all of the answers from last time, and you could just click on one thing and say, well, actually, I have a new cell number, so I'll change that and I'll click OK on everything else, and I won't have to type all the rest of it. That would be awesome. And we have some capabilities to do that. And then after the user has filled out the form, we will then perform a process called extraction, where we take the data that the user entered into the question and response and then move some of it into allergy intolerance or observation or patient for demographic information or whatever. And then if we want to, we can create a provenance resource that links those two things together to say this particular allergy intolerance data came from that questionnaire response over there. Sometimes we'll only pass around the allergy intolerance or the condition or whatever resource. Sometimes we will pass around the provenance and the questionnaire response if there's a need to have that original source of truth available. So that's sort of the base workflow around questionnaires. Questionnaire itself is a very simple data structure. We have a bunch of metadata that lets us find the questionnaire and understand what the heck it's about. And then a questionnaire has items. It can have a bunch of them. And then items can contain other items. And you can keep nesting as deeply as you want. And each item will have a type. It's either a group, which is a collection of stuff. It's a question, which is soliciting data, or it's a display where we're giving guidance and we're not nesting stuff beneath it, or soliciting data. There's some rules around these different types of things. So a group is really an organizer. We use groups if there's a collection of stuff that it needs to be optional together. We use groups if there's a collection of stuff that needs to repeat together. We use groups to just say, hey, these things are kind of interrelated, and so we'll nest them together so that we have a common label across them and it organizes them that way, and that's useful. Sometimes we use groups because they're associated with particular user interface controls. If you're using tables or things like that, then groups are probably involved. If you have a group, then you have to have children, at least if your form is done. Obviously, if you're in the process of creating a form, you might have things that are just sort of hanging there and aren't finished yet. But when you're done, your group is definitely going to have nested things under it. Those nested things might be groups as well. They might be questions, they might be display items, but when you get to the leaf level, you're dealing with either questions or display items. You can't have a leaf level group. And the other thing about groups is you don't actually have an answer for a group. So you might have a group that says next of kin. There isn't an answer to that. Instead, there are answers to the child questions, which are name and phone number and uh, relationship and whatever else you wanted to capture about that organized topic. Questions, on the other hand, are places where you are asking for information. You are saying, please tell me the gender or date of birth or most recent systolic blood pressure or whatever you happen to want to capture. Some questions will be optional, so a patient or provider or whoever is filling out the form can skip over them. And some of them will be required, which is in order to save the questionnaire as complete, you have to have an answer there. You get to decide that when you're authoring. And then display items are for all of that other text that you stick in there. If you have legal text, if you have a problem with this form, please call so-and-so, or this form is subject to such and such a privacy law, or please think about these things or these definitions as you're answering this form. Any of that kind of instructional or help or other kind of surrounding text that is not either organizing information or soliciting information. So this is probably a timely question given the time of day. So this is a sample question that you could have in a questionnaire. There's nothing about the questionnaire resource that says that questions have to be healthcare related. And in your ideal world, maybe your hospital stay does encompass being fed pizza. We can dream. So if we look at this whole structure, we've got a whole bunch of different pieces. We have 5.a, and that is a prefix, and you can control it. If you don't specify it, the form filler tool might create ones for you. But if you want to have help text that says, please consider the answers to question number 2 when you're filling out question number 5, it's kind of helpful if you can control that it's called 5 and not A or I or some other numbering scheme. Then we have the question text. For a question, this is the text of the question itself. For a group, it's the label for the group. For a display item, it's the content of the display. Then beneath that, we have a child display item. And this display item actually tells us a little bit about the metadata of this particular question. When it says choose at least one, that means you have to have an answer, which means that this is a required answer or a required question item. And the fact that you can choose more than one, which is good for pizza, you would have the item also being flagged as repeating. And then within that, we have a list of options. And those options might be codes, they might be strings, they might be dates, they might be a variety of things. They can be listed directly inside the questionnaire, or they can be a reference to an external source, to a value set that is shared across multiple forms or shared between your form and maybe other resources or profiles. And then we've got a nested question. So if you put a check mark beside other, it's going to pop up this please specify question. If you click on mushrooms or ham, it's not going to ask you that because you've already specified. I don't need you to tell me what kind of mushrooms you want because I don't have more than one kind of mushrooms to give you. And so you can have questions inside questions. And you can also have something called an enable when that says only display this in certain circumstances. In this case, it would be only display this if the answer to question 5A happens to be other, in which case you would expose it. In other circumstances, you wouldn't. And so those are the pieces of information that we would capture when we're talking about a questionnaire. If we go look at the data model and you lean really close to your screen, you can see all of the data that you could possibly capture in a questionnaire. And so that simple data model that I showed you earlier, this whole side here is the metadata stuff. So what is the title for this questionnaire? What is its identifier? What is the standard URL that you can use to find it in any server that it might be on? Is it a retired questionnaire, or is it an active questionnaire, or is it a draft questionnaire? Who wrote it? Who do I call if I have questions? Is this questionnaire for Alberta or BC or Ontario? Is this questionnaire for pediatrics or oncology or something else? Are there legal terms associated with this? Is there a period of time when you're allowed to use this version and then you have to move to a different version? We can also have a code that says the meaning of this questionnaire is this Lloyd panel or something like that. If there's a standard terminology that actually goes with the collection of data that you're gathering. And then we have our items. Every item is going to have a link ID. That's sort of the key to your particular question or group or display item. And we'll use that when we're filling out a questionnaire responses later. We can have some metadata that says, hey, the meaning of this code comes from this particular data source or this terminology. And then we've got a lot of the different items that we saw on the previous screen. We've got the text, we've got enable when behavior, we've got repeats, we've got required, and there's other various constraints that we can specify as well. And then if we want to, we can list the allowed options, and items can contain other items. And that is the structure that we use to gather any data that you can possibly imagine in the healthcare universe or elsewhere. Questionnaires, of course, aren't terribly useful if you don't actually fill them out. And in the very early days, we had a single resource that we used to both define the questionnaire and capture the data until we realized that that was a very silly idea, because the people that you want to be able to maintain the questionnaire and the people that you want to be able to maintain the responses are often different. And so it's useful to have separate resources for those things. Access control and all kinds of other things are going to be different for them. And questionnaire response has a structure that is very similar to the questionnaire. And we have these link IDs that tie them together. And here we have a group. The link ID for it happens to be G1. Link IDs can be sort of whatever you like them to be. Sometimes they're meaningful, sometimes they're not. And this particular group repeats, and that means I can have G1 in the questionnaire response more than once. I can't have G1 in the questionnaire more than once. In the questionnaire, these are a primary key. For our items, they have to be unique within the questionnaire. But depending on the repeating rules and the nesting rules, they might appear more than once in the questionnaire response. And then nested within that, we have our questions. And this question Q1 does not have repeats equals true. And the default for repeats, data absent interpretation, is repeats is false, but we still have more than one of them in the questionnaire response. And that's okay, because the rules around repeating are this does not repeat inside this group, but the group itself repeats. And so that nesting structure is still okay. So that is your high-level introduction to questionnaires and forms in FHIR. And now I'm going to dive into the deep end of the pool, which is structured data capture. Structured data capture is one of the first implementation guides that we created in FHIR. And it comes from the underlying methodology of FHIR. And in FHIR, we say we're only going to include stuff in a resource definition if it meets the 80% rule, which means that we believe that roughly 80% of the systems that will support this particular resource, so questionnaire, will actually support this data element. And we do that to keep our resources from being absolutely ginormous. We have experience. It's called HL7 version 3, with what happens when you try to create a data model that covers absolutely everything that's possible to say. You get a really large, complex data model, and it's also super abstract, which means you can represent the same thing 1,500 different ways, and everybody does that, and then you don't get the interoperability you were hoping for. So in FHIR, we say we're only going to include the common things, and then we have an extensions framework that allows us to define extra stuff that is relevant in more limited circumstances. And it turns out that questionnaire is one of those beasts that has a gazillion special circumstances. Questionnaires get used all over the place, and that means that the set of functionality you can count on across most systems is relatively limited, but there are edge cases where people want all kinds of things. And so the SDC implementation guide is our mechanism for trying to standardize those extra things that we did not standardize in the base resource. And so we cover a bunch of different things. We cover workflow, we cover rendering, we cover behavior in terms of flow through a questionnaire. We talked about populating forms. We have mechanisms to embed metadata in the form that lets you do that. We've talked about extracting data. We have the ability to embed metadata that lets you do that. We have adaptive forms that let you, rather than saying, here's the complete list of questions, you talk to a server and it tells you what the next question happens to be. And maybe that's from an internal database. Maybe it's fronting on some sort of AI system. Doesn't really matter. All that matters is that you have a way to get the next question. So we're going to drill into each of these a little bit more. In terms of workflow, the SDC implementation guide does a few things. It defines what are the typical systems that would be involved in working with forms. Because if you say, I conform to FHIR questionnaire, that doesn't really tell me a heck of a lot. I don't know what you do with it. Are you a repository of questionnaires? Do you display questionnaires and let people fill them out? Do you consume completed questionnaires and process them in some way? Are you an archiving system? And so we've defined sort of common patterns and given names to them so that you can then declare conformance with something that is meaningful. If I say I am an SDC form filler, then I know what are the basics of what that system is going to be able to do. I know it's going to be able to create and update and potentially delete questionnaire responses. I know it's going to be able to look for questionnaires and retrieve them. It's going to be able to look for and find value sets. It's going to be able to submit questionnaire responses, and it's useful to know those things. On the other hand, if I'm a form manager, I know that I'm going to be exposing things on a server interface to let people find questionnaires and possibly also find value sets and that sort of thing. In addition to that, we define standards around searching. So what are the common search parameters that everybody should support? We define expectations in terms of terminology operations, so the ability to retrieve value sets, the ability to expand value sets to say, well, the value set says all SNOMED procedure codes. I'm a very dumb iPhone application and I have no idea what SNOMED is, let alone what all the codes are. Please help me find them. And you can use the value set expand operation where somebody can start typing in appendectomy. And as they start typing, you're calling in the background and saying, expand this value set, find me things that contain AP. Now find and keep spelling appendectomy until you've got to drop down the list for the person sees what they want and they click on it and then they've got their code. We talk about the rules around completing forms. When do you validate? When is it appropriate to store partial forms, and when do you strip out populated information versus retaining it? If you're wanting to submit a form for processing, we define a standard operation for doing that. If there's a workflow where you want to say, I would like the patient to fill out this form next Tuesday, what is the mechanism that you ask for that in FHIR? How do they say that, yes, I will, or no, I haven't, or here's the completed form? How do we create one form that is based on another? So all sorts of different aspects of workflow, and we try to nail all of those down in SDC. In terms of rendering, I said earlier that one of the powers of questionnaires is that you have control over rendering. And the base questionnaire resource lets you say what the text is going to be, lets you control what the order of the questions is, lets you control the data type of the answers, lets you control what the list of choices is, if there's a list of choices. But sometimes you want more than that. You want pretty colors, or you want something to be bold, or you want something to be italic, or you want something to be a particular font size, or you want to have a grid around something. Um, Maybe there are certain questions where you want to display them and display the answers, but it's calculated. I get you to enter your height, I get you to enter your weight, and I will display you the BMI, but I'm not going to let you change that because that would be silly and leads to inconsistent data, and that's a bad thing. Sometimes there's hidden questions. So maybe you are filling out data that's already been pre-populated and you've got information about an allergy that's already in the patient's record. And some of that information is going to make sense to the user and you want it to be visible to the user. But other things like what is the primary key of this allergy record? Showing a GUID to a human being is just cruel and unusual, and we don't want to do that. And so there are certain types of questions that we might choose to hide and not make visible, but are still there in the questionnaire response because they're going to be useful later when we're trying to extract things. While the questionnaire controls the data type and whether things are required or repeats, it doesn't say what the control is. And we can infer a control. If it's repeat is false, then radio buttons make sense. If repeat is true, then checkboxes might make sense. But should it be checkboxes, or should it be a drop down, or should it be a type ahead drop down? Or maybe this group is organizing things into a table, or maybe this group is organizing things into pages that I can page through, or it's a tab-based control, or maybe this group is a header or a footer. And furthermore, I have tables and I want to control what the labels on the columns are and how wide they're going to be. Or I've got a slider and I want to control the starting position and the ending position and the increment position and all that kind of stuff. Maybe I just want to give guidance to the user as they're filling stuff in and tell them this is the format in which I want the phone number or the social security number or whatever it might be. In addition to controlling what the form looks like, we can also control how it behaves. So we've talked about enable when, where you can turn questions or groups on or off based on particular answers. That's part of the core resource, but sometimes we want to do things that are a bit more complicated than turn this on if question 3 equals A. Sometimes we want to do math. Sometimes we want to, if your score is greater than 10, then we're going to display some more questions because we're concerned. Or maybe we need to have multiple questions behaving in particular ways with and or logic in there. And we have a language that we use in Fire called FirePath that lets us write as crazy a set of expressions as you might want to express your rules. We can also have constraints. So we can set a rule that says this question is only valid if certain conditions are true. And sort of have rules across questions. So this isn't a required question, and question 2 isn't a required question, but you darn well better answer one of the two. You can't do that with just a flag on the question. It's a rule that has to exist on the group or the questionnaire as a whole that expresses that rule. And so we have extensions to do that. Sometimes we want to constrain the answers. So we have a string, but do we want a maximum length? Do we want somebody to paste in 25,000 characters? Maybe that's a little bit much for a name and it's going to make our database unhappy. So we maybe want to put a maximum. Maybe we don't want somebody to just type a dash or something and skip the question, even though it's a mandatory question. So we're going to put a minimum number of characters. We could set date ranges, we could set number ranges, we could set rules for attachments. Like I know how to take JPEGs, I know how to take GIFs, but please don't give me WordPerfect documents or something like that, because probably many of you don't even know what that is. We can set maximums in terms of size. We can set rules for units of measure. We can set the number of repetitions. The base item lets you say, does this thing repeat or not, and is it mandatory? But it doesn't set a maximum. So can I pick 5 choices? Can I pick 500 choices? What is reasonable? What is allowed? One of the cool things that you can do with a questionnaire as an electronic resource that you could never do with a paper form is you can answer a question by pointing to something that lives somewhere else in a database. FHIE has a data type called reference, and that reference data type allows you to point from one resource to another. And questionnaire allows you to have answers that are of type reference. And so you can, rather than saying, who is your primary physician, and having somebody type the name of their physician and hopefully spell it right, and maybe ask for a phone number, because maybe they know that, and you use that set of information to try and figure out who the heck their GP actually is, you could let them search against a registry and find their GP and actually have the name spelled right and know exactly who it is and be able to look up their identity and other information that is useful in other resources. But the base question or resource only lets you say the data type for this question is reference. It doesn't let you constrain it past that. And so it doesn't let you say that the answers need to be practitioners as opposed to conditions, as opposed to procedures. And it kind of matters which kind of answer you get. Furthermore, it doesn't tell you where to go look up the set of answers from. It doesn't set any constraints in terms of what the answers are allowed to be. And if you want to get really fancy, you might go look and try to find your practitioner and find that they don't exist. And so you might be given the ability to go create a new one, and they give you a new questionnaire that lets you fill out the information, and then it'll do an extraction and create the necessary record that you can then reference. So all kinds of things that we might do in terms of behavior there. More behavior, we can do calculations. So we can calculate scores. We can figure out initial values for things. We can use variables that we will use as part of the population process. And again, we have the ability to use these languages, FHIRPath, or if you want to get really fancy, CQL, to do whatever kind of manipulation that we might want to do. We also have the ability to define forms from other forms. If you have a common demographic section on all of your referral forms, it's kind of helpful if you can define that once and then use it everywhere from an authoring perspective, so that if there's a new question that we need to suddenly answer, whether it's a change to the value set for gender preference or pronouns, or we now have additional rules around addresses or postal codes. It's great if you can manage that in only one place. And so we have the ability to define what we call modular forms, where you can construct forms from other forms, or you can even construct forms from a database of questions, so that you could even have consistency in terms of questions across all of your research forms in your enterprise. There's organizations that think that's a really awesome idea because it lets them reuse data across studies a whole lot more easily. So all kinds of different things that did not make the cut in terms of 80% of systems throughout the world who handle questions will be able to do these things, but are still the types of things that are helpful and useful in questionnaires. And there's enough people who want to do them that we have defined standard mechanisms for doing those things. So next is pre-population. And pre-population was one of the initial reasons why the SDC project started. SDC was actually funded by the US Office of the National Coordinator, which became renamed ASTP. which became recently renamed back to ONC, but US government. And they wanted to be able to have questionnaires that could be pre-populated from data in existing CDA documents. And it turns out nobody ever wanted to do that because extracting data out of CDA is a pain, and CDA documents aren't necessarily terribly consistent around how that information is represented. And so that never happened. But it turns out that people were quite interested in being able to extract data from FHIR data repositories. So if you have a FHIR server that exposes conditions and patient and allergies and procedures and encounters and things like that, it is really useful to be able to go look and say, find me the most recent patient height, find me the most recent patient A1C, find me the patient address, and have those answers filled in. And it's useful for a few different reasons. One, it makes your users a heck of a lot happier because they can be more efficient. They're not having to go back and try to find that information. You just fill it in for them. It also eliminates transcription errors. So if you have somebody go look at something, it's possible that they might look in the wrong place and not find the most recent. It's possible they might transpose numbers as they're looking over there and then typing them in over here. And so this eliminates that particular problem. However, in order to do it, we need a number of things in place. First of all, we actually have to have a source of data. And so for the population that we're interested in, that means you need to have FHIR resources typically exposed over a FHIR server, although there is also currently exploration around being able to do population from FHIR documents, in particular International Patient Summary, which is a international standard for a document syntax of key healthcare information that you can carry around with you as you are traveling, going from country to country to country. And in theory, anywhere you are in the world, you can either give them your IPS document on a memory stick, or you can show them a barcode and give them permission to go and retrieve your IPS instance from wherever they are in the world. And then they can suck in your current list of allergies and drugs and health conditions and other things that are really useful when you're in an emergency room in Argentina and you don't speak the language terribly well. In addition to having that data source, we also need to have a mapping that says this particular answer in this particular question corresponds to this thing in the base FHIR data model. So whether that's a data element in patient or a data element in observation, which has for observations that have a particular LOINC code, possibly with date constraints as well. You define what the rules are for populating. It might be that if you're taking blood type, you're totally happy to grab an observation that is 30 years old. On the other hand, if you're grabbing weight, I would love it if you grabbed my weight from 30 years ago, but it probably wouldn't be terribly useful for diagnostic purposes. And of course, if you're grabbing height, it depends on the age of the patient. If the age of the patient is 50, then their height from 5 years ago is probably not changed very much. If the age of the patient is 15, their height from 5 years ago is probably different. And so you can set what those rules are. Then you need to have an engine that understands how to go and grab the information from the data source, navigate through it, apply the relevant filters, find the answer or answers that apply, and populate them. And to make any of this work, you do need to have an understanding of what the data is going to look like. It is theoretically possible to define population logic against the base FHIR model. And for things like demographics, like patient name and gender and phone number, you can do that pretty well because the data structures are nailed down enough at the international level to be able to find those things. But as soon as you get into, I want to grab your allergies, or I want to find out what your most recent A1C is, well, in order to find the A1C, you need to know how that's coded. Is that represented in LOINC? Is that represented in SNOMED? Is that represented in Dr. Bob's favorite diagnosis code system? could be any of those things. And so having an overarching model like IPS, which nails some of those things down, or CA Core Plus, which nails some of those things down, is really important. And CA Core Plus doesn't nail things down as much as we would like it to, because we don't yet have consensus across all of the jurisdictions in terms of what are the codes that they're going to use for different things. And so as that becomes more robust and more consistent, then the power of our ability to populate data goes up. In terms of population, there's a number of different mechanisms. And in fact, this slide is out of date because we added a new one last year. We can populate using just observations, and that's a simple mechanism for defining population. We just say, here's the observation code, and I'm interested in values that are no older than this duration. So I'm happy to receive your blood pressure for the last 6 months. I'm happy to receive your weight for the last year. I'm happy to receive your height for the last 5 years. I'm happy to receive your blood type for the last 50 years. You can set those rules. The power of observation-based is it's really simple to define. It does not take a whole lot of skill for whoever's authoring the questionnaire to be able to do observation-based population. They just need to be able to look up the relevant link code or SNOMED code or whatever is being used, and they need to choose a reasonable duration. The problem with observation-based is you can only populate stuff from observations. And furthermore, you can only populate stuff from observation value. If you wanted to populate from observation severity, or you want, not severity, I forget the data element name, doesn't matter. You want to populate from observation date or anything else like that, you can't use observation-based. FirePath-based lets you navigate a data structure using that FirePath language that I talked about earlier. And you can then say, this start with patient, go down to name, filter the names to only be the legal names, filter the legal names to only be the ones that don't have an expiry date on them, and then give me the family piece of that. And there should only be one of those. If there happens to be more than one, then grab the first one because it's as good as any. And you can set those kind of rules. And with that, you can go after data that lives pretty much anywhere, but there's still some limitations around how complicated you can get. Structure Map is a resource that exists in FHIR specifically for transforming from one data structure into another. And with Structure Map, you can transform data hierarchies, you can perform code translations, you can do math, you can do all kinds of things. You can turn a version 2 structure into a FHIR structure, into a CDA structure, into a comma-separated variable structure. You can do whatever you like. And it's a very powerful mapping tool. And it's also not understood by a whole lot of people in the world. And so you're, again, trading off power. You can do more for how hard is it to actually write these and make it work. Observation is easiest. FirePath is a bit harder, but is more capable. Again, Structure Map is a bit harder, but more capable. CQL is really a whole programming language, but it is a programming language that is syntax agnostic, so it doesn't care if it's dealing with JSON data or XML data or RDF data, and can run basically on any kind of infrastructure and is very much tuned to data manipulation and filtering, and you can use it as well. Going into those in a little bit more detail, for pre-population, you're going to populate your item.code. You're going to put in an extension that says what is that period of time, and you will end up with a part of my example went away. That sucks. I'll have to fix that. This is actually showing the query for the questionnaire that you can't see, which is that it's going after observations. it's filtering to the subject, which is whatever the subject of the questionnaire response happens to be. You don't need to do anything special to the questionnaire response to make that happen. And then on the question item, you would have had a list of 3 LOINC codes. And so this then says LOINC this code, LOINC this code, or LOINC this code. It'll filter for any of those. Status of completed is filled in automatically. The date is calculated by the offset period. So if the offset period was 5 years, date would have been 5 years ago from today. And then we sort by descending date. So we want the most recent one of those, and we're going to get the first one. And that is going to give us the value that we're going to use to populate the instance. So that's what observation population looks like. With FirePath population, we have the ability to actually pass in some context as well. So we can indicate things like, what is the patient that I'm looking at? What is the encounter that I'm dealing with? And so those pieces of information can be used to help through the population process to filter what conditions you're grabbing, what allergies you're grabbing, what procedures or orders you're grabbing. We have the ability to embed on the different items extensions to set context. So if I wanted to have a group that captured next of kin, I would say that the context for this is patient.contact, which is where we capture next of kin type information in the patient resource. And then each repetition of that group would correspond to a contact that existed in patient.contact. And then we would, in the questions underneath that, have initial expressions that set the values to the name for that contact, or the personal relationship for that contact, or the phone number for that contact, whatever it might be. And we also have the ability to set variables at various layers in the questionnaire if we want to pass context around. So that is FirePath. Structure map actually gets used not only actually, I'm missing some slides here too. In addition to the population side, we have the extraction side, which is how we move data from being inside of a question or response into an allergy resource or an encounter resource or whatever. Just as with population, we have multiple mechanisms. With extraction, we have multiple mechanisms. And again, there's a trade-off in terms of the different processes there. We have observation-based, we have FirePath-based, we have structure map-based. We also have a recently new one, which is template-based, where I basically just say, here's an example allergy intolerance resource, and I've just embedded extensions that tell you what question to go grab certain values from. And so I've filled in all of the fixed values in this instance, and you just use that as a template and go fill in different parts of that from the questionnaire response. And so all of these give us a mechanism to perform extraction as well. If I go into more detail in this, we'll probably be here for 4 or 5 hours, so we'll leave that part there. In terms of working with questionnaires, there's actually a wide variety of tools. Actually, I'm going to just quickly jump over to the SDC specification for a moment to give you a sense of how to find some of these things. So, if you ever want to find an implementation guide, just go to build.fire.org or hl7.org/fire, doesn't matter which. And in the header, you'll find a list for implementation guides. And this is a list of all of the implementation guides that are published by HL7 International or by an organization that has asked us to list theirs as well. And if you go here and search for SDC, you will find structured data capture, and you can go to the most recent build of that specification from there. And so if we go click on the support link, one of the tools that we have available is existing implementations. And that's a Confluence page that any implementer of SDC can come along and say, hey, I have a tool that you can use. And some of them are open source, some of them are commercial, uh, and some of them are authoring tools, some of them are form filler tools, some of them are a mixture of both, some of them are just validation tools, and you can go find those and you can use them to test your questionnaires or to create your own questionnaires. Obviously, you can just create your questionnaires from scratch using a text editor or your favorite XML or JSON editor, but that's not terribly friendly. I have done it, typically in circumstances where I need to embed extensions that my form authoring tool doesn't know how to create yet because we just invented them. But for most authoring work, you're going to want to use some sort of a friendly tool. Talked earlier about adaptive forms. The notion behind adaptive forms is that sometimes you have a really big bank of questions with a whole bunch of really complicated logic. But you're probably only going to ask 5 or 6 of those, maybe 20 at the outside, depending on how the patient answers. So sending 1,000 questions in your questionnaire is a little bit intense and may make your iPhone unhappy, depending on how new it happens to be. Furthermore, there are some organizations that say, well, no, that's my proprietary logic. I don't want you to see all of my magic questions. And I certainly don't want you to see my magic logic that determines what questions get asked and what answers are available based on what you previously asked. You have to pay lots and lots of money to do that. And so in those circumstances, we don't want to pass all of the questions in the questionnaire response. Or maybe the set of questions isn't fixed. There's some logic that actually invents questions on the fly based on what information is missing and what's already been shared. And so in all of those circumstances, we want to be able to have an interface where we can call an operation and it'll say, okay, here's your first question. And you say, here's my answer. And then you pass that off and say, what's the next question? And it comes back and says, what's your quest? And so you go through and you go back and forth. And I had put together this example of adaptive forms. And Dan Vreeman's one of the main architects of the Lloyd standard shared that hopefully many of you recognize this. If not, you should watch Monty Python and the Holy Grail. Shared that there are lots of geeks in the standards world, and there are actually standard link codes for all of those questions. But that's the process for adaptive forms: is you call an operation, and it comes back, and based on the answers that you've already given, continues to build up this custom questionnaire that is specific to this particular individual on this particular date and the answers that they have given. So that was a whirlwind tour of structured data capture IG and all of the stuff that exists in the forms world. We're now going to talk a little bit more about mapping. We've touched on this a bit already. We have 3 different mechanisms to support mapping in the FHIR standard. One is that there's a generic mapping element whenever you're profiling data. You can, just as you can override the definition or the comments or other descriptive attributes about a given data element, you can specify additional mappings for a given data element and say, this particular node in my profile corresponds to this database field, or it corresponds to this other element in that standard over there, or whatever the case might be. We also have concept maps, which is a mechanism for mapping terminology. but is also occasionally used to map structures, and we'll talk about that a little bit. And then we have structure maps, which is the tool that I talked about earlier, where you can transform any arbitrary structure into any other arbitrary structure. So for profile mappings, for Pete's sake, I love it when tools convert your uh, uh, let's go and just look at the raw spec instead, because my PowerPoint is full of beans tonight. So let's go look at uh, element definition. When you're dealing with a profile in FHIR, you're really dealing with a collection of element definitions. When you look at patient, it has a name, it has address, it has phone number or telecom. Each one of those corresponds to an element definition, and that element definition has a path that indicates where it lives in the hierarchy and what its name is. It can have definition, it can have comment, it'll have a data type that says this is a string or an address or whatever. But if we scroll all the way down to the bottom, it can also have a mapping. And the mapping will have an identity. And if we go look at the structure definition resource, one of the things that you can do at the root of your profile is define a set of mapping identities that says, I'm going to map to my database, or I'm going to map to the NCPDP standard, or I'm going to map to ISO 12345. And you can point to that specification by name or by URI. You can provide some information about the mapping overall. And once you've done that, you can then, on any of your data elements, include mappings to that thing. And so when we map, we can choose to indicate a formal mapping language. So we can actually embed in here FHIR-Path or CQL or SQL or something like that. Or we can just provide a string. A lot of the mappings in the core FHIR specification are what I call hand-wavy mappings, which is text that is semi-technical, but isn't any formal syntax and is enough to give a human being an idea of this thing kind of corresponds to that thing over there. And maybe I've got some comments that list some exceptions. Maybe I just have a comma separated list. It could be that thing or that thing or that thing. But it's certainly not something that you could ever execute against. And then if you want to, you can provide some comments around the quality of the mapping or how to interpret it. And so we have that ability whenever we are performing profiling in FHIR. We can also use this if we're using a structure definition to define a logical model, which is a structure that you can do in FHIR to define anything. We have logical models for V2 structures. We have logical models for CDA structures. You can have logical models for any kind of a hierarchical data structure. If you've got a database, you can define a logical model for that. In addition to this, we have concept map. Concept map allows us to map primarily between terminologies. So we'll show the UML map or the UML diagram of it, and we'll maybe make it a little bit bigger so it's slightly readable. Again, we've got all of this metadata on the left-hand side that tells us what kind of map this is. We then have collections of elements, and for each of these source elements, we indicate where they are mapped to. And we have the ability to be somewhat fancy in terms of setting up our rules. So rather than just saying this SNOMED code maps to this particular ICD-10 code or vice versa, we can say this code maps to that code if the body site element is this and the status is this. And so you can have combinations of elements that create a mapping. You can also express relationships. So rather than just saying A maps to B, you can be more explicit and say that there's some kind of a relationship here, which is similar to the hand wavy mapping that I've said before. You can also, if you wanted to, for some reason, say this thing has nothing to do with that thing. You wouldn't typically do that, but maybe if you have names that look kind of similar and you have a problem with people thinking that they're the same thing when they're not even close, you might choose to make that explicit. But more commonly, you would want to use one of these three narrower codes. So you can say these two things are equivalent. So means exactly the same thing as B, and if you can transform between them without worry. You can also say that we have a relationship, but the semantics are not exactly the same. One of the elements is tighter than the other, or one of the elements is broader than the other, and that has implications if you're trying to map from one set of codes to the other set of codes. With this structure, we actually also have an operation that's defined that you can execute that map and translate from one code to another. So if you are hitting a terminology server and a map is available, you can transform between ICD-10 and SNOMED or CPT and X12 codes or whatever. There are also situations where when we map things, instead of referring to code systems, we'll actually refer to data structures. And in that circumstance, instead of pointing to codes, we are pointing to paths within the data structure. And then we can do very much the same thing. We can say that this data element here is equivalent to that data element there, or is broader than, or is narrower than, or maps to that element, provided that these other elements have particular values. So we can use it in that way as well. For all FHIR resources, if you're wanting to understand, well, what does that actually mean? What does that look like? We have examples. And so you can go take a look at, this one is an example of a mapping between ICD-10 and ICD-9. Obviously, this is nowhere close to complete because it didn't make my browser blow up. But it goes through and says, okay, we're doing a group, we're mapping between SNOMED CT and ICD-10. The SNOMED code that we're going to map is this one, the target code is this, and here's the nature of the relationship. And then we go on and we do that for all of the different elements. So everything that we used to do in spreadsheets in Excel, we can now do computably. And while Excel works really nicely as a user interface for an analyst who's trying to map things, it turns out that it's not great for sucking into a computer and having the computer automatically know how to deal with it because everybody's Excel spreadsheet looks different, whereas this looks consistent. And if you wanted to, if you had a simple map at least, you could dump it out into a spreadsheet to render it anyhow. Last type of mapping I'm going to talk about is structure map. We invented this when we were looking for a way to transform between one arbitrary data structure and another. We looked at XSLT, but that's XML specific and wasn't as capable as we wanted it to do. It didn't have the terminology awareness that we wanted. We could have used JavaScript, but generally speaking, it's a bad idea to run arbitrary JavaScript that somebody else wrote in your own environment. There's security risks. I mean, you can sandbox things, but it's still a bit dicey to be doing that. And so we wanted a language that was syntax agnostic. So it didn't care whether the data was an XML or JSON or RDF or a comma-separated variable file, whatever. And would have the sophistication to handle all the different types of mapping rules that we had encountered. And so Graham actually worked with another fellow who has been doing mapping for a very long time, and they came up with a language that basically covers everything that you might want in the mapping space. It's kind of complicated and kind of ugly. Um, there are starting to be tools available where you can do drag and drop and other kinds of things uh, that handle it relatively well. Actually, let's not look at the XML. Let's go look at uh, there's actually a human readable syntax for it in addition to the computable syntax. Um, this is kind of what that ends up looking like. So you indicate what your source is, you indicate what your target is, and then you go through and you iterate and you express the rules. You can set fixed values, you can transform things, you can call subroutines, you can do whatever you need to do. There's actually in the specification a reference to the fire mapping language that defines how all of this works. So if you want to dig in deeper, that is where to go to find out more. Um, as with all things in the fire space, if you want to dig into something more deeply, you should go to chat.fire.org. If you go just to the main fire specification and go down to the very bottom, you will see this link for community discussions. It is free. If you want to post, you need to sign up, but you don't have to pay to do that. And there are 30,000 active participants at the moment, ish, probably more than that now. There are streams on every kind of topic that you could possibly imagine in the healthcare space. Some beyond that, there's a poetry stream, for example, and you can talk with other standards geeks. And if nobody there knows the answer, odds are pretty decent that there isn't a known answer. They're a very responsive community and very good at um, helping people when they're running into problems with any of the standards. It's primarily fire folks that hang out there, but there is a community there for B2, there is a community there for CDA and for other things as well. So let's go back to the deck. Final slide. So that's me. You can email me, but I'd rather if you reached out to me on chat.fire.org because that lets me forward you to the best place to help you more easily and lets me connect you with other people more easily. If you're interested in SDC, that's the link to the current official release of the specification. We just had a new release last month. We've been working up to that one for about 4 years, so that was a major event for us. And we have some time now for questions. Happy to answer questions about forms, about mappings, about fire, about standards, whatever would be helpful.
Wonderful. Thank you so much, Lloyd.